Hello there, and welcome to the Bedtime Lab. It's a pleasure to have you here with me tonight as we embark on a gentle journey through the wonders of the cosmos. Picture yourself lying back, the weight of the day slowly slipping away, as we explore the mysterious and awe-inspiring world of interstellar objects. These cosmic travelers, like the famous Oumuamua, remind us of how vast and intricate our universe truly is. Before we dive into our exploration, I'd love to know where you're tuning in from. Please feel free to share your location in the comments. It's always fascinating to see how far our little community reaches across the globe. Let me share something interesting with you. Did you know that Oumuamua, the first interstellar object detected passing through our solar system, has a name that means scout, or messenger from afar arriving first in Hawaiian? This name was chosen to reflect its origins and the excitement it brought to scientists worldwide. Imagine the thrill of discovering an object from a distant star system, quietly whispering its secrets as it sails past our sun. Speaking of Oumuamua, here's a fascinating fact. It is cigar-shaped, unlike any asteroid or comet we typically see. Scientists initially thought it might be a comet, but it lacked a tail or coma, making it more of an enigma. Can you imagine something so unusual, silently hurtling through space, leaving more questions than answers in its wake? And here's something else to ponder. Oumuamua traveled through our solar system at a speed of about 54 kilometers per second. That's significantly faster than the speed of most objects within our own solar system. This incredible velocity suggests it has been traveling through the galaxy for millions of years, carrying with it the history of unknown worlds. Now, let's consider this. Oumuamua is believed to have originated from another star system entirely. It's a true interstellar visitor, likely ejected from its home system long ago. This idea opens up a world of possibilities about the nature of other star systems and what they might contain. What if there are countless other Oumuamuas, each with its own unique story? Here's another captivating thought. The discovery of Oumuamua has led scientists to estimate that there could be thousands of interstellar objects passing through our solar system every year. Most of these, however, are too faint and too fast for us to detect. It's like knowing there are countless unseen ships sailing through a cosmic ocean right above us. Transitioning to another intriguing aspect, did you know that interstellar objects can offer clues about the building blocks of planets and stars? By studying them, scientists hope to learn more about the formation and evolution of our own solar system. It's as if each object is a time capsule from a distant past, waiting to be unlocked. And speaking of unlocking mysteries, Oumuamua's trajectory was so unusual that some scientists speculated it might even be an alien probe. While this idea has largely been set aside, it sparked the imagination and curiosity of many, reminding us that the universe still holds many surprises. Here's a thought to drift off with. Interstellar objects like Oumuamua may carry organic compounds, the building blocks of life, from one star system to another. This means they could potentially play a role in spreading life throughout the galaxy, a cosmic pollination of sorts. Imagine the possibility of life hopping from world to world, carried on these silent travelers. And finally, let me share this comforting notion. While Oumuamua has long since left our solar system, its discovery opened a new chapter in our understanding of the universe. It stands as a reminder of how little we still know about the cosmos and how much there still is to learn. Each interstellar object we encounter adds a piece to the grand puzzle of existence, inviting us to dream and wonder. As you relax into the night, let these interstellar musings soothe you. Imagine the vastness of space, the twinkling stars, and the silent passage of cosmic travelers like Oumuamua. They connect us to something greater, a universe full of mystery, discovery, and infinite possibilities. Thank you for joining me here at the Bedtime Lab. May your dreams be filled with the wonders of the cosmos, and may you find peace in the gentle embrace of the night. Let me continue with a fascinating idea. The journey of an interstellar object, like Oumuamua, is like a cosmic handshake between star systems. These objects travel vast distances and carry secrets from their point of origin, perhaps even from places we have yet to imagine. Isn't it intriguing to think of them as ambassadors from the far reaches of space, each one a potential messenger from an entirely different part of our galaxy? And speaking of distant journeys, did you know that interstellar objects often experience intense gravitational forces as they pass by stars and planets? This gravitational dance can alter their trajectories and velocities, sometimes sending them careening off in entirely new directions. It's as if the universe is playing a celestial game of pinball, with these objects as the balls bouncing and careening through space. Here's another perspective that might surprise you. Some scientists believe that interstellar objects could be remnants of failed star systems. Imagine a system that never quite formed into planets or stars, leaving only scattered debris to wander the galaxy. These fragments could tell us stories of what might have been, offering insights into the chaotic processes that shape our universe. Speaking of cosmic stories, did you know that the surfaces of interstellar objects can be altered by cosmic radiation and the harsh conditions of space over millions of years? This weathering process can create a hard outer crust, shielding the more pristine material inside. It's like a protective shell, preserving the ancient secrets within. Imagine the tales those untouched interiors could tell, of times long before they embarked on their journey through the stars. Here's something to spark your imagination. Scientists are exploring the idea that some interstellar objects might be composed of materials we have never encountered on Earth. The possibilities of finding novel minerals or compounds are tantalizing, and each discovery would expand our understanding of the universe's chemistry. Can you picture the excitement of uncovering something completely unique, something that challenges everything we know about the building blocks of nature? And while we're on the topic of unique materials, consider this. Some interstellar objects might harbor water ice deep within them, hidden beneath their surfaces. This water could have originated from the icy regions of their home star systems, providing clues about the distribution of water throughout the galaxy. Imagine water droplets traveling across the cosmos, spanning millions of years and countless light years, only to be discovered by curious minds here on Earth. Now, think about this. The sheer number of interstellar objects that pass through our solar system hints at the abundance of material floating through the galaxy. It's like a vast ocean of cosmic flotsam and jetsam, each piece on its own unique voyage. Yet, despite their abundance, these objects are infuriatingly elusive, often slipping past our instruments unnoticed. It's a gentle reminder of how much of the universe remains hidden from our view. Here's an intriguing notion. Some scientists propose that interstellar objects could occasionally collide with planets, including Earth. While such an event would be exceedingly rare, the idea that pieces of other star systems might have impacted our planet is a fascinating thought. These impacts might even have contributed to the rich tapestry of elements that make up our world today. Imagine the possibility that parts of our planet's own story involve chapters written in distant star systems, As we ponder these cosmic travelers, consider this. The presence of interstellar objects suggests that our solar system is not an isolated entity, but part of a dynamic, interconnected galaxy. It's a reminder that our place in the universe is just one piece of a much larger puzzle. These objects serve as bridges, connecting us to the broader cosmos and encouraging us to look beyond the confines of our solar neighborhood. Here's a calming idea to end with. The very act of studying interstellar objects brings people from around the world together. Scientists, astronomers, and enthusiasts collaborate across borders, united by a shared curiosity about the universe. This collective effort to understand these mysterious visitors reflects the best of human nature, our desire to learn, to explore, and to connect with the unknown. As you drift off to sleep, let these thoughts of interstellar wanderers wrap around you like a cozy blanket. Picture their silent journeys across the galaxy, each one a story waiting to be told. In their travels, they whisper to us of distant worlds and ancient pasts, inviting us to dream of the wonders that lie beyond our night sky. Let me share a thought with you. The journey of an interstellar object can be long and lonely, spanning millions of years before it reaches a solar system like ours. These objects travel through the immense voids between stars, where the gravitational pull of any one body is weak and diffuse. Can you imagine the vastness of such a journey, drifting alone through the cold embrace of space for all that time? Here's something that might intrigue you. Scientists have discovered that interstellar objects like Oumuamua can vary greatly in shape and size. Some may be elongated and cigar-like, while others might resemble more familiar, rounded celestial bodies. The diversity of their forms hints at the variety of conditions they might have experienced in their home systems. Just as each snowflake on Earth is unique, so too are these cosmic travelers, shaped by the environments from which they originate. Did you know that the speed at which these objects travel can be astonishingly fast? Some interstellar objects move at velocities exceeding several tens of thousands of kilometers per hour. Such incredible speeds are necessary to escape the gravitational pull of their original star systems, allowing them to journey across the galaxy. Imagine the energy required to propel these ancient visitors on their vast interstellar voyages. Speaking of energy, let's consider the forces these objects endure. As they traverse different regions of space, they encounter varying gravitational fields, some of which can be incredibly intense. These fields can stretch and compress them, altering their structure over time. It's like a cosmic massage, reshaping them gently as they wander through the universe. Here's a curious idea. The surfaces of interstellar objects can be coated with organic molecules formed from the interactions of solar radiation and other space conditions. These organic compounds might be similar to the building blocks of life here on Earth, sparking the imagination with possibilities about the origins of life itself. Could these traveling pieces of matter have played a role in seeding life in distant worlds? Have you ever wondered about the sounds of space? While it's silent in the vacuum, the movement of interstellar objects can be detected by the gravitational waves they create as they travel. These ripples in space-time are like the universe's own music, a symphony of motion that our instruments can sometimes capture. It's a reminder that even in silence, the cosmos is full of activity. Now, consider this fascinating possibility. Interstellar objects might serve as natural time capsules, preserving the conditions of their birthplaces within them. By studying these travelers, we might uncover forgotten chapters of the universe's history, providing insights into how star systems evolve over time. Each one carries with it a piece of its origin, a snapshot of a time and place far beyond our reach. Here's something you might find surprising. Some researchers speculate that interstellar objects could be remnants of ancient comets or asteroids that once orbited other stars. Over time, gravitational interactions and collisions might have ejected them from their home systems, setting them adrift on their interstellar journeys. These objects could be the cosmic remnants of celestial dramas that unfolded long ago. Isn't it fascinating how some of these objects, despite their alien origins, could be composed of familiar materials like rock and metal? This suggests commonalities in the processes that form planets and star systems throughout the galaxy. It's like finding a shared recipe used by star chefs across the cosmos, hinting at universal principles that govern the creation of celestial bodies. Speaking of universal principles, let's consider the idea of panspermia, the hypothesis that life might spread across the universe via interstellar objects. These travelers could potentially transport microbial life or its precursors from one star system to another, sowing the seeds of life as they go. While this remains a speculative idea, it underscores the interconnectedness of all things, even across vast cosmic distances. Here's a gentle thought to ponder. The discovery of interstellar objects like Oumuamua is a relatively recent achievement made possible by advancements in our observational technology. As our tools improve, who knows what other cosmic visitors we might find. Each new discovery expands our understanding and brings us closer to comprehending the full story of our galaxy. Have you ever thought about how these elusive travelers might inspire our future journeys into space? Observing their trajectories and velocities helps us refine our own plans for interstellar travel. Just as ancient mariners learned from the stars to navigate the oceans, so too might we learn from these celestial wayfarers, guiding us on our path to the stars. Finally, let me share this soothing thought. The existence of interstellar objects reminds us that the universe is a dynamic, ever-changing place. They are a testament to the grand ballet of celestial mechanics that shapes the cosmos, a dance that has been ongoing for billions of years. As you close your eyes tonight, let the rhythm of this cosmic dance lull you into a peaceful slumber, filled with dreams of distant worlds and the mysteries they hold. Imagine if a single interstellar object could tell us tales of galaxies far beyond our own. In a sense, they do. These objects traverse the vast reaches of space, carrying with them the stories of their origins. It's fascinating to think that as they journey across the cosmos, they might be colliding with clouds of gas and dust, picking up particles along the way. This process can create a unique fingerprint, a trail of cosmic breadcrumbs, if you will, that scientists can analyze to piece together their history. Have you ever wondered about the colors these objects might display? Depending on the materials they are made of and the light they reflect, interstellar objects can exhibit a range of hues, from deep reds to muted grays. Their coloration can provide valuable clues about their composition and the environments they've encountered. It's like a celestial palette, painting a picture of their past travels. Here's an intriguing thought. These objects are often so small and distant that they challenge our observational capabilities. Yet, despite their elusiveness, they occasionally make their presence known by glinting in the sunlight as they pass by, almost like a wink from the universe. This brief moment of visibility is a precious opportunity for scientists to gather data and learn more about these mysterious travelers. Speaking of mystery, did you know that the precise origin of Oumuamua is still debated? Some theories suggest it came from a distant star system, while others propose it might be a fragment from a larger body that was torn apart in some cosmic event. The uncertainty adds to the allure, inviting us to ponder the circumstances that might have sent it on its interstellar voyage. Now, consider the possibility that these objects might not be alone in their travels. Some scientists have speculated that interstellar objects could arrive in swarms, clusters of celestial wanderers sharing a common journey. If true, this could mean that what we observe is just the tip of a much larger cosmic iceberg, hinting at the complexity and abundance of interstellar phenomena. Another curious aspect is their potential to influence the systems they enter. As they pass through, their gravitational pull could perturb the orbits of planets and asteroids, subtly reshaping the dynamics of these systems. It's a gentle yet profound reminder of how interconnected the universe truly is, where even a solitary traveler can leave a lasting impact. Let me share with you something captivating. Some interstellar objects might be remnants of failed planet formation processes. Imagine a star system attempting to form planets, only to have some material cast out into the void. These remnants could provide insights into the workings and failures of planet formation, offering glimpses into the processes that might have occurred in our own solar system's past. And did you know that our own solar system might harbor interstellar visitors as well? It is possible that some objects in our midst, quietly orbiting our sun, are actually interstellar in origin, having been captured long ago. This idea opens up a fascinating perspective on the diversity and history present within our celestial neighborhood. Imagine, too, the extreme conditions these objects endure. Some interstellar travelers might pass close to massive stars where intense radiation could alter their surfaces. Others might drift through frigid, dark regions of space, preserving their original state for eons. Each path they take is a testament to their resilience and adaptability in the vastness of the cosmos. There's also the notion of interstellar objects as carriers of secrets about the evolution of galaxies. By studying their isotopic compositions, scientists can infer the types of stellar processes that occurred in their home regions, providing valuable data on the life cycle of stars and the formation of elements. Have you ever considered how these objects might challenge our understanding of physics? Their rapid speeds and distances demand precise calculations and models. Each discovery pushes the boundaries of our knowledge, prompting us to refine our theories and examine the universe with ever more curious and open minds. Speaking of discoveries, the detection of interstellar objects is often a team effort, relying on the collaboration of astronomers around the world. Their shared observations and analyses create a global community united in the pursuit of knowledge. It's a beautiful example of how the quest for understanding transcends borders, bringing humanity together in exploration. And here's a final thought to carry with you. While interstellar objects are indeed rare, each one we detect is a doorway into the vast unknown. They remind us of the infinite possibilities the universe holds and the endless mysteries waiting to be unraveled. As you drift off to sleep, let these thoughts of cosmic wonder fill your dreams, paving the way for new discoveries and adventures in the mind's eye. Let me start by painting a picture for you. Imagine an object soaring through the darkness of space, its surface possibly covered with a layer of organic molecules, akin to the building blocks of life. Some scientists have speculated that interstellar objects might carry these organic compounds across the galaxy, potentially seeding life on distant planets. This idea is known as panspermia, a captivating concept that stirs the imagination about the origins of life in the universe. And here's a curious thought. Interstellar objects like Oumuamua travel at incredible speeds, often much faster than anything within our solar system. This velocity is not just a physical property, but a clue to their long journey across the cosmos. At such speeds, they can escape the gravitational pull of stars, sailing freely through the galaxy. Can you imagine the incredible vistas they might pass by on their journey? Speaking of journeys, these objects can travel for millions of years before reaching our solar system. During this time, they might experience countless close encounters with other celestial bodies, each encounter subtly altering their trajectory. It's fascinating to think about the cosmic dance that guides them, a choreography written by gravity and time. Did you know that one of the ways scientists detect these interstellar objects is by tracking the light they reflect? When light from the sun or another star bounces off an object, it creates a bright spot that telescopes can pick up. The brightness and color of this light provide essential clues about the object's size, shape, and composition. It's like reading a story written in light, deciphering the secrets of these elusive travelers. Here's something to ponder. While Oumuamua is the most famous interstellar object, it is likely not the first to visit our solar system. It's simply the first one we've been able to identify as such. This realization suggests that countless other objects may have passed through unnoticed, each one a silent messenger from the stars. What if I told you that interstellar objects might also reveal secrets about the conditions in the early solar system? By comparing the compositions of these objects with known solar system bodies, scientists can infer similarities and differences that hint at the processes that shaped our planetary neighborhood. It's like having a time capsule, offering a glimpse into the past. Another intriguing aspect of interstellar objects is their potential to carry water ice. Imagine an object journeying through space, carrying with it frozen water that might date back billions of years. If these objects were to impact a planet, they could deliver this precious resource, potentially aiding in the development of life. It's a thought that links the vastness of space with the intimate necessities of life as we know it. Speaking of impacts, some theories propose that interstellar objects might have contributed to the formation of our own moon. The idea is that collisions with large interstellar objects could have played a role in the moon's creation, adding an interstellar twist to the story of our closest celestial neighbor. The moon, it seems, might carry traces of these ancient travelers within its very soil. Let's consider the sheer variety of interstellar objects. They are not limited to rocky bodies like asteroids or icy comets. Some might be dense, metallic fragments, remnants of dying stars. Others could be porous, fragile structures formed in the coldest regions of space. This diversity makes each new discovery a unique opportunity to learn more about the universe. And can you imagine the challenges involved in studying these objects? Their incredible speeds and unpredictable paths make them fleeting targets for observation. Yet, each successful observation enriches our understanding and fuels our desire to seek out more of these cosmic wanderers. The pursuit is a testament to human curiosity and the enduring quest for knowledge. Here's something that might surprise you. Interstellar objects could also teach us about the future of our solar system. By studying how these objects interact with stars and planetary systems, scientists can make predictions about the long-term stability and evolution of our own cosmic home. It's a glimpse into what might lie ahead, stretching from the past into the distant future. And finally, consider the idea that interstellar objects might be more common than we think, hidden in plain sight among the countless bodies that populate our solar system. As our observational techniques improve, we might find that these cosmic visitors are a regular part of our astronomical landscape, each one holding keys to understanding the broader universe. So, as you close your eyes and drift into slumber, Let your thoughts wander among these interstellar travelers. Picture their journeys, the secrets they guard, and the mysteries they might one day reveal. Allow the gentle ebb and flow of cosmic wonder to cradle your dreams, carrying you across the stars. And now, let your imagination take flight as we explore the intriguing notion that some interstellar objects might possess magnetic fields of their own. These fields, though faint, could interact with the magnetic fields of stars and planets they pass by, creating subtle but fascinating effects. Imagine the delicate dance of magnetism, bending cosmic winds and influencing charged particles in space. Speaking of magnetic wonders, did you know that some interstellar objects may contain materials rare even in the vastness of space? Elements such as gold or platinum could be more concentrated in these celestial travelers, potentially mined from the remnants of ancient supernovae. Picture a glittering treasure trove drifting silently through the galaxy, a legacy of stars that once blazed with unimaginable brilliance. Here's a thought to ponder. The surfaces of interstellar objects are often altered by cosmic radiation during their long voyages. This constant bombardment can change their color and texture, offering clues about their age and the environments they've traversed. It's as if each object carries a cosmic passport, stamped with the signatures of countless encounters. Consider this intriguing fact. Some scientists speculate that interstellar objects might have hollow interiors, akin to the caverns and tunnels found on Earth. These hollow spaces could provide stable environments, shielding any precious cargo from the harsh conditions of space. Can you imagine a journey through such a hidden realm, where the echoes of the cosmos whisper ancient secrets? And here's something unexpected. Interstellar objects could potentially act as natural spacecraft. Their trajectories, shaped by gravitational forces, might allow them to hitch rides on stars, traveling vast distances without any need for propulsion. It's a remarkable testament to the power of celestial mechanics, reducing space travel to a graceful, effortless glide. Let me share another captivating idea. The shape of interstellar objects can vary wildly, from elongated cigar-like forms to more spherical shapes. These unique geometries are shaped by their origins and the forces they've encountered. Imagine an artist sculpting with the winds of time, crafting each object into a distinct work of cosmic art. Speaking of artistry, have you ever wondered how these interstellar objects are named? The names often reflect a blend of cultural heritage and scientific discovery. For instance, Oumuamua is a Hawaiian term meaning scout or messenger, highlighting its role as a harbinger from beyond. Each name adds a layer of human connection to these enigmatic visitors. Here's a delightful surprise. Some theories suggest that interstellar objects might carry the seeds of microbial life, potentially dormant within protective layers. If these microbes were to find a hospitable environment upon arrival, they might spring to life, carrying on a lineage of cosmic explorers. It's a thought that blurs the lines between biology and astronomy, linking life to the stars. Have you ever considered that the paths of interstellar objects might serve as natural laboratories where scientists can test theories about the formation of galaxies and star systems? By observing how these objects interact with various cosmic phenomena, researchers can gain insights into the forces that shaped our universe. It's like unraveling a vast cosmic puzzle, one piece at a time. Speaking of puzzles, did you know that the discovery of interstellar objects often involves a global effort? Astronomers around the world collaborate, sharing data and observations to track these fleeting visitors. This spirit of cooperation is a beautiful reminder of how the quest for knowledge unites us, transcending borders and cultures. Here's an intriguing notion. Interstellar objects might bear witness to events that occurred long before the birth of our solar system. Their journeys could have taken them through supernova remnants or past newly formed stars, each experience leaving a subtle mark. It's like reading a cosmic history book, with each chapter revealing a new layer of understanding. And consider this: as technology advances, we might one day send spacecraft to rendezvous with interstellar objects. These missions could allow us to study their composition up close, unlocking mysteries that have eluded telescopes for generations. Imagine the thrill of exploring an object that has traveled across the galaxy, revealing secrets from the depths of space. Speaking of secrets, did you know that some interstellar objects might contain traces of elements not found anywhere else in our solar system? These exotic materials could provide unique insights into the chemical processes that occur in distant regions of the galaxy. It's like discovering a new palette of colors, each hue telling a story of cosmic alchemy. Here's something to contemplate. The very act of observing interstellar objects can inspire new questions, sparking curiosity and driving scientific inquiry forward. Each discovery opens doors to fresh possibilities, encouraging us to look deeper and dream bigger. It's a reminder that the universe is a vast, mysterious place, ripe with potential for exploration. And finally, as you let these thoughts gently settle, consider the possibility that interstellar objects might hold the key to understanding our place in the cosmos. They serve as messengers, bridging the gap between distant stars and our own world. As you drift into a peaceful sleep, let the wonder of the universe wrap around you like a warm blanket, inviting you to dream of endless possibilities among the stars. Imagine for a moment that the journey of an interstellar object isn't just a straight path through the cosmos. These objects can undergo complex, winding travels, influenced by the gravitational tug of various celestial bodies they encounter. Each gravitational nudge can alter their trajectory, sometimes dramatically, leading them on unexpected detours through the galaxy. This ever-changing journey means that by the time they reach our telescopes, they've carried with them a history of galactic wanderings that can span billions of years. Here's a thought-provoking idea. The surfaces of interstellar objects are often coated with organic compounds, forming a crust that protects the material beneath from cosmic radiation. These compounds can darken the surface, making these objects harder to detect against the inky backdrop of space. It's as if they wear a cloak of invisibility, challenging our technology to find them amidst the vast darkness. Thinking of invisibility brings to mind another fascinating fact. Interstellar objects like Oumuamua move so swiftly through space that they often only give us a brief window of opportunity to observe them. Their speed is a reminder of their origins outside our solar system, propelled by the gravitational forces of their home star, sending them hurtling through the galaxy at incredible velocities. This fleeting nature makes each observation a race against time, adding a sense of urgency to the quest for knowledge. Have you ever wondered how scientists determine the age of these elusive travelers? It's a bit like unraveling a celestial mystery, where clues are gathered from the object's composition, trajectory, and surface features. By piecing together this evidence, researchers can estimate how long the object has been journeying through space, revealing stories of ancient origins and distant beginnings. Speaking of origins, did you know that interstellar objects might come from regions of space where star formation is particularly active? These bustling nurseries of cosmic creation are filled with the raw materials for new stars and planets. An interstellar object ejected from such an environment carries with it a snapshot of the conditions present in these distant stellar cradles, offering a glimpse into the birthplaces of stars. Let's consider the potential for discovery here. The study of interstellar objects has the power to transform our understanding of the universe. Each object we observe adds richness to the tapestry of cosmic knowledge, providing new data that can lead to breakthroughs in how we perceive the structure and dynamics of galaxies. These visitors act as ambassadors from far-off regions, bringing with them clues that can unlock the mysteries of space. Here's a delightful surprise. The sheer variety in the composition of interstellar objects means that each one can tell a different story. While some might be rocky and metallic, others could be icy, carrying frozen water and other volatiles. This diversity mirrors the wide range of environments from which they hail, akin to a traveling library where each book is a unique tale of cosmic history. Can you imagine the excitement of discovering an interstellar object that contains elements or isotopes that are rare or even unknown on Earth? Such a find could offer a rare opportunity to study materials that have been shaped by forces and conditions completely alien to our solar system. It's a reminder that the universe is vast and filled with wonders beyond our current comprehension. Sometimes, the best surprises come when we least expect them. Interstellar objects can be found in unexpected places, like the outskirts of our solar system where they might be lurking among the comets and asteroids. Their presence there can challenge existing models of solar system dynamics, prompting scientists to revisit assumptions and refine their theories in response to these new cosmic players. Here's something that might stir your imagination: the idea that interstellar objects could one day serve as stepping stones for human exploration of the galaxy. If future missions could harness these objects as waypoints, they might enable travel between distant star systems, opening up the possibility of interstellar voyages that are currently the stuff of science fiction. Consider this intriguing notion. As our technology continues to advance, we might develop the capability to capture an interstellar object and bring it closer to Earth for detailed study. Such an endeavor would be a monumental achievement, allowing us to analyze its composition and structure in ways that are impossible from afar. It would be like bringing a piece of another star system into our own backyard, a tangible connection to the vastness beyond. And finally, as you allow these possibilities to dance gently in your mind, think about the interconnectedness of space. Each interstellar object is a thread in the cosmic web, linking us to distant star systems and ancient galaxies. They remind us that while we are bound to our own planet, we are also part of a much larger, more wondrous universe. As you drift into slumber, let the mystery and beauty of interstellar objects guide your dreams, kindling a sense of awe and curiosity that carries you into the realms of the night sky. Did you know that some interstellar objects could be the remnants of long-lost star systems? Imagine a scenario where a star, once vibrant with planets and other celestial bodies, meets a cataclysmic end. The debris from such an event, ejected into the cosmos, might become the interstellar travelers we observe today. It's as if they carry messages from vanished worlds, whispering tales of stellar death and rebirth. Speaking of stellar events, there's a captivating thought: the possibility that an interstellar object might have passed close enough to a black hole to be affected by its intense gravitational pull. This encounter could stretch and distort the object, altering its trajectory and composition. Can you picture the incredible forces at play during such a cosmic dance? Here's another fascinating tidbit. Some interstellar objects might contain within them tiny pockets of gases that have been trapped since their formation. These gas pockets, could provide a unique insight into the chemical environments of distant regions of space, offering a direct sample of alien atmospheres. It's like opening a time capsule from another corner of the universe, filled with clues about the conditions that prevailed billions of years ago. Let me share something intriguing. The idea that interstellar objects might have been shaped by collisions with other celestial bodies during their journey through space. Such impacts could alter their surfaces, create craters, or even cause them to fragment into smaller pieces. This constant reshaping means that by the time they reach us, they have become a patchwork of history, each scar a testament to past encounters. And here's a surprising notion. The magnetic fields of interstellar objects could be relics of the magnetic environments they once inhabited. These magnetic fields might be detected through subtle interactions with solar winds or other charged particles. By studying these fields, scientists can glean information about the magnetic properties of their regions of origin, providing a rare glimpse into the hidden forces that permeate the galaxy. Have you ever considered the possibility that some interstellar objects might contain organic molecules similar to those that led to the emergence of life on Earth? This raises tantalizing questions about the universality of life's building blocks and suggests the potential for life to exist in forms and places vastly different from our own. It's a humbling reminder of the diverse possibilities that the universe holds. Here's something to ponder. The surfaces of interstellar objects are exposed to intense cosmic radiation during their travels, which can significantly alter their chemical composition over time. This radiation can create exotic compounds that are not found naturally on Earth, offering a natural laboratory for studying the complex interactions between matter and radiation in space. Each object becomes a canvas painted by the universe's energetic forces. Imagine this: the idea that interstellar objects might pass through multiple star systems during their journeys, experiencing different gravitational pulls and environmental conditions. Each encounter adds a layer to their story, like chapters in a book that chronicle a life spent wandering the galaxy. These objects become living records of the changing landscapes of the cosmos, their paths shaped by the stars they encounter. It's remarkable to think that interstellar objects might also serve as natural probes, collecting dust and particles from the regions they traverse. Like travelers gathering souvenirs, they accumulate material from various star systems, allowing scientists to study these cosmic dust samples when the objects come within reach of our instruments. This cosmic dust collection offers a unique opportunity to analyze material from otherwise inaccessible parts of the galaxy. Consider this: the gravitational interactions between interstellar objects and our solar system can sometimes result in these objects being captured temporarily, becoming part of our solar family for a brief time. During this period, they might adopt orbits similar to comets or asteroids, only to be flung back into the vastness of space after their short stay. It's a reminder of the dynamic nature of our cosmic neighborhood. Here's a thought-provoking concept. The sheer number of interstellar objects passing through our solar system might be far greater than we currently estimate. With advancements in technology, such as more sensitive telescopes and detection methods, we might soon discover that our solar system is regularly visited by these cosmic wanderers. This raises the possibility of ongoing encounters that could inspire a new era of exploration and discovery. Lastly, imagine the poetic symmetry in the journey of interstellar objects. As they traverse the galaxy, they might occasionally return to regions close to their origins, completing a vast cycle through space. This cosmic journey reflects the interconnectedness of the universe, where each object plays a part in the grand tapestry of celestial movements. The idea that they could return home, even after eons, speaks to the enduring ties that bind the cosmos together. As these thoughts drift through your mind, let them inspire a sense of wonder about the universe. Each interstellar object is a messenger from the stars, carrying with it the secrets of far-off places and times. As you gently close your eyes, imagine the possibilities that await us as we continue to explore these otherworldly travelers, forging connections with the unknown and deepening our appreciation for the vastness that lies beyond our reach. Let me tell you about a captivating detail regarding interstellar objects like Oumuamua. Their shapes can be extraordinarily diverse. While most asteroids and comets within our solar system tend to be somewhat rounded due to collisions and gravitational forces, interstellar objects can have elongated or even bizarre shapes, untouched by the forces that typically mold celestial bodies. Can you picture an object as long and slender as a skyscraper tumbling through space? This unusual geometry might arise from the intense gravitational forces they experience as they slingshot around stars, stretching them into these peculiar forms. Here's another interesting aspect to consider. Interstellar objects often travel at incredible speeds, much faster than the objects native to our solar system. This velocity hints at the tremendous forces that have propelled them on their journeys across the galaxy. It's as though they are the race cars of the cosmos, speeding through the vastness of space with a sense of urgency and purpose. Imagine the kinetic energy they must carry, potential energy stored over countless light years, ready to be released upon interacting with a new solar system. Surprisingly, these objects may also carry with them traces of ancient supernovae, colossal stellar explosions that have seeded the galaxy with heavy elements. As they pass through the remnants of these cosmic blasts, they can collect particles and isotopes, embedding them in their structure. This makes them like pieces of a cosmic puzzle, each carrying a fragment of the explosive past of the universe. Did you know that interstellar objects might dim and brighten in peculiar ways as they travel through space? Unlike comets and asteroids whose brightness ebbs and flows predictably, the light curves of interstellar objects can be irregular and unexpected. This erratic behavior is often due to their unusual shapes or tumbling motions, offering scientists a delightful challenge as they attempt to decipher these celestial signals. Have you ever imagined the colors of these objects? Interstellar objects can have a range of hues, from the dark, carbon-rich surfaces that absorb light to the reflective, icy exteriors that gleam brightly against the backdrop of space. These colors are not mere aesthetic details. They provide important clues about the materials that make up the objects and the environments they have traversed. Each shade tells a story of elemental composition and cosmic history. Speaking of composition, some interstellar objects are believed to contain exotic ices, formed under high-pressure conditions that are rare in our solar system. These ices could include combinations of water, carbon dioxide and other gases that are frozen solid, revealing conditions that existed in the farthest reaches of the galaxy. It's akin to discovering a new type of mineral that opens doors to previously unknown geological processes. And here's something truly astonishing: the possibility that certain interstellar objects might be hollow. This isn't just a flight of fancy. Theoretical models suggest that during their formation, some objects could have developed voids or cavities. These hollow spaces could influence their dynamics and stability, offering yet another layer of complexity to their already fascinating nature. Think about the notion that interstellar objects are like celestial messengers, carrying with them the gravitational signatures of the star systems they've passed through. As they move, they could carry imprints of past gravitational interactions, like a cosmic fingerprint left by the stars that tugged at them. Analyzing these gravitational signatures might help us understand more about the star systems they've visited. Here's a thought that stirs the imagination. Some scientists speculate that interstellar objects might harbor dormant life forms tucked away in protected environments during their long journeys through space. While purely hypothetical, this idea ignites our curiosity about the resilience of life and its potential to exist beyond Earth. Could these objects be silent ambassadors, carrying life to new worlds? Consider the possibility that interstellar objects could influence the formation of planets and moons. As they pass through young star systems, they might seed protoplanetary disks with rich materials contributing to the building blocks of new celestial bodies. This sharing of cosmic materials hints at a universe interconnected by the flow of resources, suggesting that planet formation might be a more communal process than we ever imagined. Imagine this. As scientists develop more advanced technologies, we might one day capture an interstellar object and bring it to Earth for study. This audacious idea could open a new chapter in space exploration, allowing us to analyze, in detail, the materials and structures of these enigmatic travelers. The insights gained could reshape our understanding of the universe, offering tangible samples from beyond the solar system. Let me share a final thought to ponder. The beauty of interstellar objects lies not only in their physical attributes, but also in what they represent, a bridge between the familiar and the unknown. They are reminders that the universe is vast and mysterious, filled with wonders yet to be discovered. Their journeys inspire us to look beyond our own world, to seek answers to questions that have yet to be asked, and to dream of the possibilities that lie in the distant reaches of space. As you drift into a peaceful slumber, let these marvels of the cosmos dance in your mind, each fact a glimmering star in the night sky of knowledge. Imagine the thrill of spotting a visitor from another star system. One such visitor that captured the world's attention was Oumuamua, a name that means scout in Hawaiian. Did you know that Oumuamua's discovery in 2017 was a milestone, as it was the first known interstellar object to pass through our solar system? Its cigar-like shape and unusual acceleration puzzled scientists and sparked numerous theories about its origin. Speaking of shapes, another intriguing aspect is that interstellar objects might not conform to the usual spherical or elliptical outlines we're accustomed to seeing in our solar system. Instead, some can be elongated or even flat like a pancake. This unusual geometry can affect how they tumble and move through space, creating complex rotational dynamics. Have you ever wondered what makes these objects so fast? Oumuamua, for instance, zipped through our solar system at speeds exceeding 150,000 kilometers per hour. Such velocities suggest these objects are ejected from their home systems with great force, possibly through interactions with giant planets or even gravitational slingshots around stars. These tremendous speeds are necessary to overcome the gravitational pull of their home stars, allowing them to embark on interstellar journeys. Here's a fascinating thought. Interstellar objects might be more common than we think, stealthily crossing our solar path regularly. It's estimated that there are about 3 to 5 such objects passing through the inner solar system at any given time. However, due to their small size and high speeds, most of them go unnoticed, like shy guests at a cosmic party. Think about this. Some interstellar objects may carry with them complex organic molecules, the building blocks of life. These molecules could have formed in the dense molecular clouds of their birthplaces, providing essential ingredients that might spark life elsewhere. In this way, they could be seen as delivery vehicles, sowing the seeds of life across the galaxy. Intriguingly, these travelers can also teach us about the early solar system. As they pass by, they might capture dust and debris, preserving them in their icy mantles. This cosmic sampling could offer clues about the conditions and chemical compositions present during the formation of our own sun and planets, acting like a time capsule from the galactic neighborhood. Now consider this. The surface of an interstellar object can reveal much about its history. For instance, their surfaces might get cooked by intense radiation as they drift through space, altering their appearance and offering insights into the harsh environments they've endured. The cosmic rays they encounter can create a patina, a weathered layer that tells tales of their ancient travels. Here's something to stimulate your imagination. What if some interstellar objects are remnants of shattered planets? Catastrophic collisions in distant star systems might have fractured entire worlds, sending fragments careening through space. If true, these remnants could provide invaluable information about planetary compositions and tectonic activities beyond our solar system. Have you ever thought about the trajectories of these objects? Their paths can be influenced by the gravitational fields of the stars they pass, but also by the Yarkovsky effect, a process where uneven heating by sunlight causes them to slowly drift in their orbit over time. This subtle force can change their courses significantly during their extensive travels. Here's a curious detail. Some interstellar objects might be coated with a layer of organic-rich material, which gives them a reddish hue. This coating could be a result of complex chemical reactions initiated by ultraviolet light, transforming simple molecules into more complex organic compounds. Such processes hint at a universe where chemistry is as dynamic as it is varied. It's also worth noting that these objects don't always travel alone. Sometimes they might be accompanied by dust or smaller fragments, like a cosmic entourage. This entourage can provide additional clues about the object's origin and the environment from which it sprang, offering a more complete picture of its story. Now imagine this. The study of interstellar objects isn't just about understanding what lies beyond. It also challenges our perceptions of what constitutes a solar system. By observing these wanderers, we begin to see our solar system as part of a larger interconnected web of star systems where exchange and interaction are ongoing processes. Some scientists have even proposed that interstellar objects could be used as natural spacecraft. Their high speeds and stable trajectories make them ideal candidates for hitching a ride to distant parts of the galaxy. If we could develop the technology to latch onto these objects, we might unlock new horizons in interstellar travel. Have you ever considered the sounds these objects might produce as they travel through space? While space is a vacuum, with no air to carry sound, the interactions of these objects with cosmic dust and solar winds might generate vibrations or electromagnetic signals. These songs of interstellar objects could be unique to each traveler, offering yet another dimension to their mystery. Picture this. As we continue to advance our detection methods, interstellar objects could become regular features in our astronomical maps. Their presence might one day be as routine as spotting a comet, each one a reminder of the vast unexplored reaches of our galaxy. They invite us to dream and explore, to reach beyond the known and touch the stars themselves. As you drift into slumber, let the whispers of these cosmic wanderers fill your mind, guiding you through the mysteries of the universe. Astronomy has always been a field full of wonder and surprises, and interstellar objects like Oumuamua continue to capture our imagination with their intriguing mysteries. Have you ever thought about how these cosmic travelers might have originated from binary star systems? It turns out that such systems, where two stars orbit a common center of mass, may be particularly efficient at ejecting material into the interstellar medium. The gravitational dynamics involved can give these objects the necessary velocity to escape, setting them on a journey across the galaxy. Speaking of journeys, did you know that interstellar objects can be incredibly diverse in their chemical compositions? While some might resemble icy comets from our own solar system, others could be rocky or metallic, indicating they might have originated from varied environments. This diversity suggests that these objects might represent a cross-section of the galaxy, each one a unique blend of its stellar nursery's conditions. Here's an intriguing idea. These objects can serve as natural laboratories, offering insights into physical processes such as space weathering and radiation exposure. As they travel, the surfaces of interstellar objects are constantly bombarded by cosmic rays and solar radiation, altering their chemical and physical properties. This ongoing transformation can help scientists understand how similar processes might affect bodies within our own solar system over time. Imagine this. The shape of an interstellar object can also be a clue to its origins. While Oumuamua's elongated shape was quite unique, suggesting perhaps a shard of a larger body, others might be more spherical or irregular. These shapes could hint at their formation processes, whether they were once part of a larger planetesimal, a chunk of a disrupted planet, or formed in the outer reaches of a distant star system. Interestingly, the brightness of an interstellar object can fluctuate dramatically as it tumbles through space. These variations in brightness are caused by the object's rotation and irregular shape, creating a sort of cosmic light show for astronomers on Earth. Observing these fluctuations helps scientists determine the object's rotation period and understand its physical properties better. Here's another captivating possibility. The surfaces of these objects could potentially harbor biomarkers, indicators of past or present biological processes. While this is still a speculative idea, the presence of complex organic molecules on some asteroids and comets in our solar system suggests that interstellar objects might also carry such signatures, providing tantalizing hints of life beyond Earth. Have you ever considered the potential for mining interstellar objects? Their unknown compositions might include rare or valuable materials, such as precious metals or isotopes not commonly found on Earth. Mining these objects could one day become a reality, offering new resources to fuel technological advances and space exploration. Now, think about how the discovery of more interstellar objects could refine our understanding of the galaxy's history. Each object carries with it a story of cosmic events, from star births and deaths to the formation of planets and asteroids. By studying these visitors, astronomers can piece together the evolutionary timeline of the Milky Way, gaining insights into the processes that shaped our galaxy. Here's something that might surprise you. The gravitational pull of our own planets can subtly alter the paths of these interstellar travelers, a phenomenon known as gravitational lensing. This interaction can be so pronounced that it sometimes redirects their path entirely, making them permanent members of our solar system or sending them off on a new trajectory altogether. Speaking of gravitational forces, have you ever wondered how they might affect the internal structure of an interstellar object? These forces can cause stress within the object, potentially leading to fragmentation or reshaping, which in turn affects its future interactions with other celestial bodies. Consider this. As we improve our detection methods, we might discover that some of these objects are remnants of failed star formations. During the chaotic early days of starbirth, Not all material coalesces to form a star. Some fragments may be expelled into space. These remnants could offer insights into the processes that govern star formation and the conditions required for a star to successfully ignite. Intriguingly, the trail left by an interstellar object as it passes through a solar system can have a lasting impact. These trails might seed solar systems with dust and organic material, subtly influencing the evolution of planets and potential life within that system. This cosmic gardening could be a common phenomenon silently shaping the future of distant worlds. Here's a thought-provoking concept. Could these interstellar visitors bring with them the seeds of life to other worlds? Known as panspermia, this theory suggests that life exists throughout the universe, distributed by meteoroids, asteroids, and comets. Interstellar objects, with their long journeys and complex compositions, might play a crucial role in this cosmic narrative, spreading the building blocks of life far and wide. Lastly, consider the potential for interstellar objects to challenge our current models of how the universe operates. Each new discovery forces scientists to revisit assumptions and refine theories, pushing the boundaries of our understanding. As more of these celestial visitors are detected, they will undoubtedly contribute to a deeper knowledge of the cosmos, inspiring future generations to look up at the stars and wonder what lies beyond. As you drift into a tranquil sleep, let your mind wander with these interstellar emissaries, exploring the limitless possibilities that await us in the vast expanse of the universe. Have you ever pondered how these interstellar objects might interact with the atmospheres of planets they pass by? When an object like Oumuamua moves through a planetary system, its high velocity can cause atmospheric disturbances, potentially triggering meteor showers or auroras. These interactions, though fleeting, can offer clues about the atmospheric composition of the planets involved. It's as if these celestial visitors are whispering secrets to the planets they encounter. Now, imagine the surfaces of these interstellar objects as cosmic canvases, painted over eons by the forces of space. Their exposed surfaces bear the marks of micrometeorite impacts, solar flares, and cosmic dust. This constant bombardment not only alters their appearance, but also provides astronomers with a timeline of their travels, a sort of astral diary etched in rock and ice. Speaking of timelines, did you know that interstellar objects could be exceptionally ancient, perhaps older than our own solar system? Formed in distant star systems long before ours, these objects are like time capsules preserving the conditions and materials from their birthplaces. Studying them allows scientists to glimpse into the distant past, offering a window into the early universe's mysteries. Consider the possibility that some interstellar objects might possess magnetic fields of their own, created by their internal compositions or past interactions with other celestial bodies. This magnetism can affect how they interact with solar winds and magnetic fields of the planets they encounter, providing a unique perspective on the magnetic dynamics of space. Here's something truly fascinating. The color of an interstellar object can reveal a wealth of information about its composition and journey. The hues we observe are influenced by the materials on its surface and the radiation it encounters. A reddish tint might suggest organic compounds, while a more metallic sheen could indicate a rich mineral content. Each color tells a part of the object's story, painting a vivid image of its celestial adventures. Have you ever thought about how interstellar objects might influence scientific instruments and observations here on Earth? As these objects pass through our solar system, they can cause anomalies in radio signals, affect satellite trajectories, and even impact the readings of ground-based observatories. This means that they serve as natural calibration tools for our technology, helping scientists fine-tune their instruments and improve detection methods. Let's delve a little deeper. Some scientists speculate that interstellar objects might one day be used as interstellar probes themselves. With minimal modifications, these naturally occurring bodies could be equipped with scientific instruments and sent on even longer journeys, gathering data from remote star systems and transmitting it back to Earth. This concept of hitchhiking on these cosmic travelers might redefine our approach to space exploration. Here's a thought-provoking scenario. What if interstellar objects carry with them the remnants of ancient civilizations? While this idea is purely speculative, it's a captivating thought that these objects could be vessels of long-lost knowledge, fragments of alien technology, or even art from distant worlds. It reminds us of the boundless possibilities that lie beyond our understanding. Consider the temperature extremes that these objects endure during their travels. As they journey through the void of space, they experience incredible variations in temperature, from the freezing cold of deep space to the intense heat as they near a star. These changes can cause physical stress, potentially revealing layers of material beneath the surface as they crack and peel away like layers of an onion. Did you know that interstellar objects can be affected by the gravitational pull of black holes they encounter? As they pass near these massive celestial entities, their paths can be dramatically altered or even lead to their complete disintegration. This interaction provides astronomers with valuable insights into the enigmatic nature of black holes and the gravitational forces at play in our universe. Have you considered how interstellar objects might impact the search for exoplanets? Their presence can introduce new variables into calculations and modeling, affecting the precision of measurements needed to detect distant worlds. Understanding their influence is crucial to refining our methods of planet detection and expanding our knowledge of potential habitable planets. Think about the impact of these objects on space missions as well. As humanity ventures further into space, understanding the trajectories and characteristics of these interstellar visitors becomes essential to ensuring the safety and success of deep space missions. Their unpredictable paths could one day intersect with those of spacecraft, making them an important focus of ongoing research. Now, let's explore a more artistic side of these celestial travelers, the tales and myths they inspire. Throughout history, the appearance of unusual objects in the sky has sparked stories and legends across cultures, often seen as omens or divine messages. Modern interstellar discoveries continue to fuel our imaginations, encouraging new narratives and artistic interpretations that bridge science and storytelling. Finally, as you reflect on the vastness of space and these interstellar visitors, you might wonder what future discoveries await us. Each new object detected could unlock secrets of the cosmos we never imagined, pushing the boundaries of our understanding. As we continue to observe and learn, the universe reveals itself as a dynamic, ever-evolving tapestry, with interstellar objects as the threads weaving through its expanse. Let your thoughts drift with these concepts, pondering the endless possibilities that these cosmic wanderers bring to light. Imagine the journey of an interstellar object not just as a simple linear path, but as a complex dance influenced by gravitational forces and cosmic winds. These travelers can follow trajectories that are anything but straightforward, weaving through the galaxy in loops and spirals that defy our expectations. One particularly intriguing aspect is their ability to gain momentum from gravitational interactions, a process known as a gravity assist or slingshot maneuver. This technique is similar to what spacecraft use to boost their speed without expending fuel, only in this case, it's the pull of planets or stars altering the course of these cosmic wanderers. Speaking of speed, Did you know that interstellar objects are among the fastest moving bodies we can observe? Oumuamua, for example, zipped through our solar system at an astonishing speed of about 85,000 kilometers per hour. These speeds are a testament to the immense gravitational forces they encounter and the vast distances they traverse. It's incredible to think about the relentless pace at which these objects move, covering enormous stretches of space in relatively short periods. Now, let's consider the possibility that interstellar objects could harbor simple organic molecules, the building blocks of life. The presence of such molecules is suggested by the spectral analysis of some of these objects, indicating that the ingredients for life might be more widespread across the universe than we once thought. This leads to fascinating questions about the potential for life beyond Earth and the role these objects might play in spreading organic material across the galaxy. Another surprising fact is that interstellar objects could be remnants of rogue planets. A rogue planet is one that has been ejected from its original star system, wandering the galaxy alone. In the chaotic environment of space, some of these planets might collide or break apart, sending fragments out into the cosmos. These fragments, in turn, could become the interstellar objects we observe, each one a piece of a larger, once whole world. Consider the surfaces of these objects, which might appear deceptively smooth but are actually covered in a layer of cosmic dust and ice. This surface layer acts as an insulating blanket, protecting the inner materials from the harsh conditions of space. However, as they approach stars, this protective coating can sublimate, changing directly from a solid to a gas and revealing the hidden layers beneath. This process can dramatically alter their appearance and even their trajectory, as jets of gas and dust propel them in unexpected directions. Have you ever imagined the sounds these objects might make as they interact with solar winds? While sound as we know it can't travel in the vacuum of space, the charged particles from solar winds can create electromagnetic vibrations that are detectable by instruments on Earth. These vibrations can be converted into sound waves, translating the silent passage of an interstellar object into a haunting symphony of cosmic music. Here's another enchanting thought. Some interstellar objects might have existed long enough to witness the birth and death of stars. Can you picture an object silently observing as bright, young stars ignite, and then watching as they fade and explode in spectacular supernovae? Over billions of years, these objects could have traveled through star-forming regions, witnessing the life cycle of stars and the formation of new solar systems. As we think about time, consider how difficult it is to predict the future paths of interstellar objects. Their trajectories are influenced by countless variables, including the gravitational pull of nearby celestial bodies and the effects of cosmic radiation. This unpredictability makes tracking these objects a challenging yet rewarding endeavor for astronomers, who must constantly adapt their models to account for new data. Now, let me share something that might surprise you: the potential for interstellar objects to transport exotic minerals and elements across the galaxy. These objects could contain rare materials formed under unique conditions in distant star systems, materials that may not exist in our own solar system. Studying such samples could reveal new aspects of stellar chemistry and the processes that govern the universe. And here's a curious twist. Some interstellar objects might have tails like comets, but they aren't caused by the same mechanisms. Instead of being formed by the sublimation of ice, these tails might be composed of electrically charged particles, forming as the object interacts with the solar wind. This phenomenon provides additional clues about their composition and the environments they've traveled through. Finally, Have you ever wondered about the potential for interstellar objects to collide with other celestial bodies? While the probability of a direct collision with Earth is low, it's a possibility that astronomers take seriously, monitoring the skies for any signs of such an event. These collisions could have profound implications, potentially delivering new materials to planets or even influencing their geology and climate. As you let these thoughts swirl around your mind, consider the vastness of the universe and the myriad of stories each interstellar object carries with it. From their ancient origins to the secrets they may hold about life and the cosmos, these cosmic travelers remind us of the endless wonders that lie beyond our own world. Drift into a restful state, knowing that the universe is full of mysteries waiting to be uncovered, each one a thread in the magnificent tapestry of the cosmos. Imagine for a moment the sheer size of space and the countless interstellar objects silently traversing its expanse. Did you know that some of these objects could be as small as a grain of sand? While we often think of interstellar objects as massive, many are actually minuscule, traveling through the cosmos unnoticed. These tiny travelers, in their own quiet way, contribute to the vast cosmic tapestry, hinting at the diversity and scale of the universe. Here's something fascinating. The colors of interstellar objects can tell us a lot about their composition and history. Some objects might appear reddish due to the presence of complex organic compounds, while others might have a more metallic sheen, hinting at a rich mineral content. These colors, a result of billions of years of exposure to cosmic radiation and the interstellar medium, offer a glimpse into the environments these objects have encountered. Speaking of environments, consider the extreme temperatures interstellar objects must endure. When far from any star, they are enveloped in the frigid cold of space, temperatures that can plummet to a few degrees above absolute zero. Yet as they approach a star, they face intense heat that can drastically alter their surface and composition. This duality of conditions creates a dynamic history etched into their layers. Here's another interesting thought: the potential for interstellar objects to be carriers of ancient information. As they travel through the galaxy, they collect particles and radiation, documenting cosmic events over millions or even billions of years. These objects might hold clues to past supernovae or the changing conditions of the galaxy, acting as time capsules preserving the history of the universe. Have you ever considered the possibility that some interstellar objects might be artificial in origin? While speculative, this idea has captivated scientists and enthusiasts alike. The unusual trajectory and rapid spin of objects like Oumuamua have led some to ponder whether they could be remnants of alien technology or probes sent from distant civilizations. It's a thought that sparks the imagination, reminding us of the endless possibilities beyond our understanding. And what about the role of interstellar objects in shaping young solar systems? When these objects pass through star-forming regions, they can collide with or be captured by young planets, influencing their development. This interaction might introduce new materials or even alter the planet's orbit, playing a subtle yet significant role in its evolution. Consider the vast distances interstellar objects travel. They often journey for millions of years across the galaxy, crossing the boundaries of multiple star systems. In doing so, they weave intricate paths, their journeys influenced by the gravitational ballet of stars and planets. Each passage through a new region leaves its mark, gradually altering their trajectory and composition. Here's a surprising fact: some interstellar objects might have once been part of binary star systems. When one star in such a system ends its life in a dramatic supernova, the gravitational balance can be disrupted, sending objects hurtling into interstellar space. These remnants of stellar dance carry with them the story of their dramatic ejection and the life and death of their parent stars. Have you ever imagined the impact of cosmic rays on interstellar objects? Over time, these high-energy particles bombard the surfaces of these objects, causing chemical reactions that can alter their physical and chemical properties. This process, known as cosmic ray spallation, gradually erodes the surface, creating a unique weathered appearance. Speaking of surfaces, the crust of interstellar objects could be quite different from anything found in our solar system. Imagine layers of exotic ices and minerals, perhaps even forms of matter that are rare or unknown to us. These surfaces, shaped by the distinctive conditions of their home star systems, offer a tantalizing glimpse into the diversity of the cosmos. As we ponder the nature of these objects, consider the role they might play in the panspermia hypothesis. This idea suggests that life could be spread throughout the universe via interstellar objects, traveling from one star system to another. If these objects carry simple organic molecules or even microbial life, they could seed planets, sparking the beginnings of life in distant worlds. Here's a curious possibility. Interstellar objects might hold clues to the dark matter that pervades our universe. Some theories propose that these objects could interact with dark matter in ways we have yet to fully understand. By studying their behavior and composition, we might uncover new insights into this mysterious component of the cosmos. Lastly, let your mind wander to the idea that interstellar objects could be linked to the formation of our own solar system. Some of the materials in interstellar objects might mirror those that existed in the early solar nebula, offering a window into the conditions that led to the birth of our sun and planets. By studying these objects, we can piece together a more complete picture of our origins and the forces that shaped our celestial neighborhood. As these thoughts swirl around, let them gently guide you into a peaceful state of rest. Each interstellar object carries with it a story as unique as a fingerprint, a testament to the wonders of the universe and the endless mysteries yet to be unveiled. Imagine, if you will, the vast expanse of the universe. Among countless stars and planets, interstellar objects like Oumuamua drift silently, each a solitary traveler on a cosmic journey. Did you know that the speed at which these objects travel can be quite astonishing? Oumuamua, for instance, sped through our solar system at about 95,000 kilometers per hour, a speed that hints at the immense gravitational forces it has encountered along its journey. This rapid pace suggests a strong push from its point of origin or encounters with other stellar bodies that increased its velocity. Have you ever wondered about the shape of these celestial wanderers? Oumuamua, with its unusual elongated form, sparked widespread curiosity. Most known asteroids and comets in our solar system are roughly spherical. The cigar-like shape of Oumuamua might indicate that it has been sculpted by unique forces such as collisions or tidal forces during its travels through different star systems. This distinct shape offers clues into the tumultuous past it might have experienced. Here's a thought that might surprise you. Some interstellar objects could be remnants of planets or moons that were torn apart by gravitational forces. When an object ventures too close to a massive star or black hole, the intense tidal forces can rip it apart, scattering fragments into space. These fragments may then wander the galaxy as interstellar objects, carrying with them the history of catastrophic cosmic events. Did you know that the potential for water ice on interstellar objects is quite significant? While they travel through the cold reaches of space, water ice can form and remain stable. This ice, once thought to be limited to comets and icy bodies in our solar system, could be abundant on interstellar objects as well. When such objects pass close to a star, the ice sublimates, potentially creating a temporary atmosphere and giving us a brief glimpse of their hidden treasures. It's fascinating to consider the possibility that interstellar objects might harbor unknown chemical compounds. The extreme environments they have traversed could lead to the formation of exotic chemicals that do not naturally occur on Earth. These compounds could offer insights into chemistry beyond the confines of our planet, expanding our understanding of the possibilities for life and the diversity of matter in the universe. Let's ponder for a moment the idea that some interstellar objects might have originated from the outer edges of our own galaxy. These regions, filled with ancient stars and primordial material, could be spawning grounds for objects that eventually get flung towards the galactic center. As they travel, they collect material and information, becoming cosmic historians of sorts, chronicling the passage from the edges of the Milky Way to its bustling core. Imagine the intriguing possibility that interstellar objects could act as probes for future exploration. As our technology advances, the idea of hitching a ride on these naturally occurring spacecraft becomes ever more tantalizing. Sending instruments aboard an interstellar object could allow us to study their journey firsthand, gathering data from regions of space we have yet to visit. Here's a surprising notion: the magnetic fields of interstellar objects. While we often think of planets and stars as possessing magnetic fields, these traveling bodies could carry remnants of magnetic fields from their parent systems. These fields might influence the particles around them, creating unique auroras or interactions that could be detected from afar, providing another layer of mystery to unravel. Consider for a moment the gravitational interactions that guide the paths of interstellar objects. As they pass through different star systems, their trajectories are altered by the gravitational pull of planets and stars. These gravitational assists can either slow them down or propel them to even greater speeds, shaping their journey across the galaxy in an intricate dance of celestial mechanics. Did you know that the discovery of interstellar objects is becoming more common as our observational techniques improve? With advances in telescopes and detection methods, we are identifying more of these elusive travelers than ever before. Each new discovery adds to our understanding, offering fresh opportunities to study the universe's vastness and complexity. Speaking of discoveries, imagine the potential for interstellar objects to contain precious metals or rare elements. As they collect material on their journeys, they might pick up elements that are scarce on Earth, potentially holding valuable resources that could be tapped in the future. This notion turns them into cosmic treasure chests, waiting to be explored and utilized. Here's a thought-provoking idea: the potential for interstellar objects to influence the orbits of planets they pass by. When an object of significant mass travels near a solar system, its gravitational pull can cause subtle shifts in the orbits of planets, altering their trajectories over time. This gentle nudge can have long-term effects on the stability and evolution of planetary systems, a reminder of the interconnectedness of all cosmic bodies. Finally, let me share the idea that these objects, though often solitary, may occasionally travel in clusters. Groups of interstellar objects, bound together by their common origin or through gravitational interactions, might journey through the galaxy as a pack, like cosmic nomads on a shared quest. This possibility opens up new avenues of research, as scientists seek to understand the dynamics of these clusters and their impact on the regions they traverse. As we reflect on these fascinating facts, let your mind wander through the vastness of space, where each interstellar object whispers the secrets of its journey, inviting us to uncover the mysteries of the universe, one gentle revelation at a time. Let your imagination drift to the idea of interstellar objects being time capsules from the early universe. These ancient travelers could contain material that dates back to the formation of the first stars and galaxies. Imagine holding in your mind's eye a fragment of cosmic history that predates our solar system. In this way, interstellar objects can serve as messengers from a time long before Earth existed, offering us a glimpse into the conditions of the early universe. Have you ever considered that interstellar objects might contribute to the spread of life across the galaxy? Known as panspermia, this intriguing theory suggests that life could travel through space on the surfaces of asteroids or comets, potentially seeding life on other planets. While no direct evidence has been found yet, the notion that interstellar objects could act as carriers of life is a tantalizing one. If true, it would mean that these celestial travelers play a crucial role in spreading the seeds of life across the cosmos, linking distant worlds in a web of biological connection. Here's something to ponder. The surfaces of interstellar objects might be covered in a layer of organic compounds. These compounds, formed through chemical reactions over eons, could provide clues about the building blocks of life and the evolution of organic chemistry in space. Engaging with the idea of these cosmic bodies as laboratories for organic chemistry allows us to dream about the possibilities of life existing in unexpected forms, far from the familiar conditions of Earth. Speaking of unexpected forms, have you ever wondered about the possibility of interstellar objects having had atmospheres? While most are likely airless due to their small size and lack of gravitational pull, there's a chance that some larger ones could retain a thin atmosphere. As they journey through interstellar space, these atmospheres might change with each stellar encounter, providing a dynamic canvas of chemical interactions and climatic shifts. Consider the idea that interstellar objects could be remnants of failed star systems. Sometimes, during the formation of a star and its planetary system, not all material successfully coalesces into planets. These leftovers can be ejected from their home star system, becoming interstellar wanderers. The thought that these objects are the remnants of cosmic dreams that never fully materialized adds a layer of poignancy to their solitary travels. Here's a surprising thought. Interstellar objects might leave behind trails of dust and debris as they traverse the galaxy. Much like a comet's tail, these trails could stretch for millions of kilometers, providing a fleeting glimpse into their composition and history. If we could study these trails, we might uncover insights into the materials that compose these objects and their interactions with the interstellar medium. And have you considered the possibility of interstellar objects harboring micrometeorites on their surfaces? As they travel through space, tiny particles colliding with them might embed themselves in their outer layers. These micrometeorites could offer a unique record of the cosmic dust and particles floating through the galaxy, allowing us to study the composition of interstellar space indirectly. Did you know that the colors of interstellar objects can be quite telling? The surface of each object reflects the composition and age of the material, with different elements and compounds imparting various hues. By examining these colors, astronomers can deduce what the objects are made of and how they have changed over time, providing us with a vivid palette to interpret their cosmic stories. Imagine for a moment that interstellar objects could serve as natural shields against cosmic radiation. As they pass through different regions of the galaxy, their solid masses could absorb and deflect high-energy particles, potentially offering protection to any life forms clinging to their surfaces. This protective ability could mean that these objects act as sanctuaries for life forms, traveling vast distances through harsh cosmic environments. Here's another fascinating insight. The trajectories of interstellar objects could be influenced by the dark matter halos surrounding galaxies. While dark matter is invisible and elusive, its gravitational effects are profound. As interstellar objects pass through these halos, their paths might be subtly altered, hinting at the unseen structure of the universe and offering clues to the nature of dark matter itself. Have you thought about the idea that some interstellar objects might be rich in carbon? This element, essential for life as we know it, forms complex molecules and structures. The presence of carbon-rich interstellar objects could suggest that the building blocks of life are more common across the universe than we previously imagined, sowing the seeds for life wherever conditions allow. Lastly, let's consider the potential for interstellar objects to be studied as natural laboratories of physics. Their interactions with cosmic rays, magnetic fields, and other forces present unique opportunities to observe physical phenomena that cannot be reproduced on Earth. By examining these interactions, scientists can test theories and refine their understanding of the fundamental forces that shape our universe. As we close our eyes to the wonders of these cosmic travelers, let our minds remain open to the mysteries they carry. Each fact, each notion, contributes to a greater understanding of the universe and our place within it. With every discovery, we draw a little closer to unraveling the secrets held by these interstellar nomads, inviting us to dream about the vast, uncharted expanses that await beyond the stars. Let me take you on another journey. Have you ever imagined that interstellar objects might be part of ancient star clusters? As they drift through space, some may have once belonged to families of stars, moving together in clusters before being cast adrift by gravitational forces. These solitary wanderers, now separated from their stellar siblings, carry with them the history of their original stellar environments, like cosmic time capsules. Here's a thought that might surprise you. The surfaces of interstellar objects could reveal intricate patterns formed by space weathering. Over time, exposure to cosmic rays and solar wind etches unique signatures onto these surfaces. Each pattern tells a story of the object's journey, much like the wrinkles and lines on a beloved old map. By studying these weathered surfaces, scientists can trace the paths these travelers have taken across the galaxy. Did you know that some interstellar objects might have experienced heating events during their distant past? As they pass close to stars, the intense heat can cause their ices to vaporize and reform, potentially altering their composition. This star-driven transformation could mean that these celestial objects have undergone significant chemical changes over time, shaping their current states. Imagine if interstellar objects could have once been part of multiplanetary systems. Before being expelled into the vastness of space, they might have orbited alongside other planets, moons, and asteroids. The dynamics of such systems can be incredibly complex, and understanding the reasons behind their ejection could unlock new insights into the life cycles of planetary systems. Here's an intriguing idea. Interstellar objects might act as natural magnets. Some of them could have metallic cores, which, when cooled, retain magnetic properties. As they traverse the cosmos, these magnetic fields might interact with the charged particles in space, creating fascinating phenomena that we are only beginning to understand. Speaking of interactions, have you considered that interstellar objects might provide a glimpse into the birthplaces of stars? As they travel, they occasionally pass through regions where new stars are forming. By studying these objects, we might uncover clues about the conditions in these stellar nurseries, offering us a window into the processes that give birth to stars and, potentially, planetary systems. Here's something to ponder. The possibility that interstellar objects could have complex rotational dynamics. Some of them may not rotate smoothly, but instead tumble through space, their axis shifting unpredictably. This tumbling motion can affect their trajectory and the way they interact with sunlight and cosmic radiation, adding another layer of complexity to their study. Imagine for a moment that interstellar objects might be covered in a thin film of volatile compounds. As they journey through space, this film could evaporate and recondense, creating a dynamic surface that changes with each encounter with a star or other cosmic body. This ever-shifting coat might contribute to the diversity of appearances we observe in these wandering objects. Here's another captivating thought: the potential for interstellar objects to be remnants of ancient collisions. In the chaotic environments of young star systems, collisions between protoplanets and other bodies can eject fragments into the void. These fragments, now interstellar travelers, could tell tales of violent beginnings and the birth pangs of planetary systems. Did you know that some interstellar objects might be ancient beyond our comprehension? Formed in the early days of the universe, they could have witnessed the birth of galaxies and the evolution of cosmic structures. These ancient objects floating through the universe carry the stories of epochs long past, offering a tangible connection to the infancy of the cosmos. Consider the possibility that interstellar objects might harbor the seeds of future planets. As they travel through space, they might accumulate material, growing larger and more complex over time. If they encounter the right conditions, these objects could serve as the cores around which new planets form, playing a crucial role in the ongoing cycle of cosmic creation. And here's a final thought to dream on: the notion that interstellar objects could help us understand the boundaries of our solar system. By observing their paths as they enter and exit our neighborhood, scientists can refine their models of the solar system's edge, where the sun's influence wanes and interstellar space begins. This boundary, known as the heliopause, is a frontier of exploration and discovery, and interstellar objects are our guides. As we drift through thoughts of these cosmic wanderers, let us carry with us the wonder and curiosity they inspire. Each interstellar object is a messenger from the far reaches of space, inviting us to explore the mysteries of the universe and our place within it. With every fact we uncover, we gain a deeper appreciation for the intricacies of the cosmos and the interconnected tapestry of celestial phenomena that stretches across the sky. As you settle into rest, let your dreams carry you on a journey among the stars, where the interstellar objects whisper their secrets to the night.